Who here uses Sean's network? Who here uses the VRS network? Okay. And out of you users, who owns a base station as well, in addition to working within the network? Okay, so you've got redundant tools already. RTX, consider as your positioning insurance. Can you get the next one for me? Oh. RTX is a technology. Consider this your positioning insurance. It's going to be another tool in your toolbox to use in addition to your base station and your VRS login, for real-time corrections. What most of you are using is a VRS network, your base, but you know that there's some challenges with that. Maybe you set up your base station, but you need to go down the road a little bit further. Do you want to hopscotch that down? You're working in the network, but you're in an area where the cell coverage maybe isn't the best, or you're in some of those extreme areas of the state where there is not a base station to provide you with that network coverage. RTX will be able to provide you the insurance to be able to continue to work in those environments. It's going to keep you very efficient out in the field so you don't have any downtime. So what is Trimble RTX?
I only do by G.
Okay. So it's a real-time GNSS correction technology. It's precise point positioning, which is different than your RTK or your RTN solutions. So what we're doing is we're taking a network of base stations around the world, we're collecting data from those, and we're modeling out the errors that you see in the ionosphere, and we're then providing you with a correction stream via satellite or over IP, depending on your situation. It is a true multi-GNSS positioning system. So any of the GNSS satellites that are up in the sky that are producing good data, we're going to collect and use those in our solution. It is not a new service. This is something that we started back in 2011. The same team that produced the software for the Trimble VRS networks, pivot software that Sean's using, is the same team that produced RTX. So you've got the same group of engineers that have been working on this, for decades. We're constantly increasing the users. We'll go through some of the improvements that have been made on RTX. Right now, we have over 150,000 users around the world, and that's improving every day. As RTX has gotten more robust over the years, the convergence time has been cut down, the accuracy has been improved, and more people like you in the room here have been using it. When it was first launched, it wasn't quite as accurate, it took a little bit longer to converge. So we had a lot of mappers and farmers, using the service. But now as we've developed it over the years, it's becoming more and more a useful tool for folks like you in the room here. You really are working untethered. You don't have to lug around a base station. You don't have to worry about cell coverage. You don't have to worry about am I in coverage of the network or not. So it really does unburden you and untether you from some of those constraints. We like to say no base, no radio, no cell. Well, here's your solution. We can provide this to you pretty much in those middle of nowhere areas, that Sean was pointing out in the Utah network. Those remote locations where you don't have good cell coverage, where you don't have a base station. This is where RTX can shine. And, as I mentioned, this is a Trimble proprietary system. This is coming from the same, group of German engineers that started VRS. Yes, that.
Does it perform under tree canopy?
It will. You still have to have good survey practice. And especially if you're using like a Trimble R12i, you're going to see very good performance under tree canopy, but you still need to maintain good survey practice. So if you're in a deep valley under heavy tree canopy, it's not going to work in a mine, things like that. You still have to have a view of the sky. You still have to track 5 GNSS satellites in addition to the RTX signal. Next slide, please. And this would be a quick video that just kind of walks through the technology. It's about a 2-minute video that shows you how RTX works and just some of the technology that's behind it. I think you have to hit it twice for it to run. Hopefully the sound's going to play. Maybe not.
Okay, stop. And go back to Teams.
Oh, sorry, Troy.
It's okay.
No, it's so go to share, stop sharing. And then share again. And then see that little toggle? Yeah, there you go.
The video, trust me, does a better job than me doing a lot of hand movements for 2 or 3 minutes to try to explain this.
Still nothing.
Are designed to deliver RTK level precision by resolving biases for your rover in real time. The service corrects small inaccuracies that occur on the satellite clock to mitigate clock error. It addresses the effects of satellite orbits being perturbed by the gravitational forces of Earth, Moon, and Sun to resolve the orbit error, and applies ionospheric and tropospheric models to immensely reduce the impact of the atmospheric
I
error.
can't see it.
Trimble RTX corrections are generated by using satellite measurements from a global, real-time reference station.
Couldn't see it online. Geez.
There you go now. Yeah.
It's just on YouTube. Yeah.
Network, which tracks all
I
GNSS.
want to go back to the beginning though. If I just do this. One more time, folks.
Okay, now they're seeing it.
There we go.
The Trimble RTX correction service set new performance standards for precise point positioning technology starting in 2011 and continues to lead the way in the field today. Trimble RTX corrections are designed to deliver RTK level precision by resolving biases for your rover in real time. The service corrects small inaccuracies that occur on the satellite clock to mitigate clock error. It addresses the effects of satellite orbits being perturbed by the gravitational forces of Earth, Moon, and Sun to resolve the orbit error, and applies ionospheric and tropospheric models to immensely reduce the impact of the atmospheric error. Trimble RTX corrections are generated by using satellite measurements from a global, real-time reference station network which tracks all GNSS constellations. These stations receive raw data and relay them to the cloud server to create models and compute high-accuracy, real-time corrections. The reference station network provides redundancy, and if one fails, you will continue to receive high-accuracy GNSS corrections built on the remaining network. Trimble RTX also provides certainty in your measurements, as baselines to the reference stations are calculated to your point simultaneously rather than relying on a single baseline from a traditional base station. With continuously evolving global constellation systems, we have more satellites available to use for your real-time correction stream than ever before. Utilizing all modern constellations and tracking more satellites means that obstructions that limit signal availability or decrease signal quality have less impact on the overall performance. Delivered worldwide via geostationary satellites, the Trimble RTX service complements your RTK solutions, including when you need true mobility and independence from base stations, cellular networks, radios, or modems. Trimble RTX correction service can help you accelerate your operations, protect productivity, and simplify workflow.
Having the technology that I could up here with some stationary slides. But the idea is that it's going to deliver a very similar accuracy to what you're going to get from a VRS network or a longer baseline solution anywhere in the world, really. These are going to be the main types of services I think that you would run into, that you would be using, in addition to your base station. So you've got the VRS network. It's going to provide the tightest accuracy, up here with, 2 centimeter horizontal, 3 centimeter vertical. It works with any type of RTK hardware. So that's a real benefit if any of you have mixed fleets and you're not using all Trimble hardware here. It's delivered in different mount points. You have different mount points so you can get, different types of datums, as well. I think the weakest link is that it's delivered over cell. You heard Sean mention that as well. Again, he has a very good tight network, but he doesn't control AT&T or Verizon. Even if you're working next to a cell tower and you're in a situation, where you're right in the middle of the network, but maybe that cell is near the university or it's near a hospital, or it's rush hour and a lot of people are coming out, you're going to get some latency in your data. RTX isn't going to be hit, with that because it's delivered via satellite. But you can see some of the differences are in the accuracy. So we can still provide a 2 centimeter horizontal. The difference is going to be in the vertical. It's a little bit less accurate in the vertical, and that's just because it's a PPP solution. It's just part of the physics behind it. So that's why, using a base station or VRS network is what we consider the gold standard. It's always going to give you your best level corrections. This is coming up on something that's almost just as good, but without, relying upon those physical pieces on the ground. One thing I want you to take away, though, is that I keep talking about RTX. Consider RTX a technology, and from that technology, we can offer different solutions to you. So Centerpoint RTX that I'll talk about towards the end is a standalone solution. You can have a subscription to Centerpoint RTX and use that as your real-time correction source. It's going to be good if you're working across the country, if you're working in some of those remote areas, long corridor projects. Maybe this will work better in those situations. With the same subscription, you also have xFill. xFill is your backup that I was talking about. So with one subscription, you have backup to your RTK, to your VRS, or you can also use it as a real-time standalone correction source. But I think, the key here is that you've got another tool in your toolbox to keep you productive out in the field. So I already went through a couple of these. Some of the challenges that you may run into, out in the field is working on those remote sites, like I mentioned. If there's some sort of single signal interruption, either by a line of sight to your base station, or you're getting too far out of the network away from one of these places, cell coverage is pretty poor. If you're working with single base and that long baseline, you're using a long baseline, you're going to see error in your solution, and it's not going to be as tight as it would be if you were, say, a quarter mile away from your base. For us, it's a differentiator. This is Trimble proprietary. It gives you the full solution when you're using Trimble gear. So for us, we like to put the whole package together and give you the best that you could possibly use out there. And again, it's coming from, I think, one of the most trusted names in the industry. Trimble, but I'm a little biased myself. The value is it's your uptime, it's your productivity. That you're adding this into your solution. So xFill, you're going to maintain your accuracy. You're going to start in RTK. You're going to start in VRS Now. For whatever reason, you lose that signal. Your receiver and the access software is smart enough to know that you've lost that signal. And if you have a Trimble RTX subscription, it transitions over to RTX to give you that backup. Yes, sir.
So I noticed on the previous 2 slides ago, the compatible devices, they're listed here. You've got the R2 as a device that's supported. What about the DA2? Can they take advantage of this?
The DA2 uses Catalyst, and part of this solution is part of Catalyst. So the Catalyst subscription gives you access to whatever the best signal is in your area, and RTX is part of that. So how does this work? Sorry, thank you. So you can see, you're working out in the field. You've either got your single base, or in this situation, you're in the network. You get a blockage, or the cell goes out. Well, your receiver is always tracking that RTX L-band satellite in the southern hemisphere in the background. It's collecting data, but it's not using it into your solution because you've got a good RTK solution. But once you get the signal, once the receiver gets the signal that there's some sort of degradation, some sort of loss in your RTK, it then switches over to RTX. And it does it seamlessly, in transitions in the background. Next slide, please. I think the key here, and this is something that's changed in the last maybe 3 years, is it will continue, you will continue to work in your local data. Before there was a change and it went to ITRF, because this is a global solution, it's delivered in ITRF. But who in here really works in ITRF? I'm sure there's very few people that use that in their daily workflow. So that was a barrier for folks like you to use it. Now through the Trimble Access software, what it does is it's going to transform from ITRF to your local coordinate system, and all of your data is going to remain in that local coordinate system. No change, no work to do back in the office. Trimble Access, next slide, please, is very good about letting you know the transition from, if xFill is not ready, you're working in RTK, that it is ready, that you've got enough data from your RTK solution. It's tracking the satellite in the background. You can see when the satellite takes over and when it's starting to provide data to you. So it's very clear from the icons when the transition takes over, and you will know where your information is coming from. So that's really xFill as your backup solution. As I mentioned, you can also use RTX, Centerpoint RTX, as your primary correction source. You can go back and forth, between the two, but if you're working, let's just say your project takes you to another state where there is no VRS network, there is no local network, to log into, RTX is a great solution. You're still going to get 2 centimeter horizontal, you're going to get 5 centimeter vertical, good, tight, accuracy that you can rely on, and you can collect it in your own data. So some of the benefits, and I think we've gone through most of these already, very high accuracy. We've been able to cut the convergence time down to a sub-minute. I think in most areas in the United States, you're probably looking at maybe 20 seconds, 30 seconds to converge down to the 2 centimeter accuracy. If there's anybody that used RTX maybe 4 or 5 or 6 years ago, I would encourage you to try it again. It is a completely different solution than it was before. It's quick, where before maybe you had to wait 15 minutes. We're using all the GNSS constellations. We're bringing them all in, so it is future-proof. You don't have to have a radio. You don't have to have a base station. You don't have to have a SIM card. It's just delivered via satellite. As long as you can see the southern hemisphere, you are good to go. Coverage around the world, like I mentioned, and no hidden costs. It's just a yearly subscription that you would buy, same as you would with your VRS subscription. I hit on these already too. We're continuously evolving RTX. So, the engineers don't rest. They're constantly working on the models, trying to improve upon them, see if we can improve upon the accuracies, get those convergence times down, provide RTX, maybe around the poles where we don't before. You are always going to see some improvements here. And all you need to do is have a subscription. You just need to have the right hardware and a subscription. We're doing all the magic in the background for you and making this the best service that we possibly can. I like this scatter plot. Thanks, Joy. I like the scatter plot because it really shows you the accuracies, precisions that you're dealing with. So the brown in the middle there, that first circle, that's your short baseline RTK. You're never going to get better than that. That is the gold standard. Outside of that, you can see what a VRS network provides you. And, that's going to be in that greenish color, the yellow data that's collected there. So you can see good accuracy, good precision. RTX is right there. It's the next one out. Your accuracies there, precision's maybe just a little bit different, than you would see with VRS, but it's a different beast. But the accuracies that we provide at the end of the day are very much the same thing. So, and I'm running out of time. So really what I just want to show you is the similarity in the data, and you can rely on this out in the field the same as you can with everything you've been using for the past, couple decades. I did mention it before. Next slide. This is your positioning insurance. So with one subscription, you can use it as your backup to your traditional methods of collecting data, or you can use it as a standalone. But add this as a tool, in your toolbox, just to keep you moving and keep you efficient. Get more jobs, make more money at the end of the week. It's just, one more thing to have to keep you moving. Next slide, please. I would very much encourage anybody, like I said, who hasn't used it, if you have capable hardware that we haven't put a subscription on before, or you haven't had a demo, we'll give you a free 30-day trial to go out and use it and kick the tires. So you can scan this, you can set it up yourself. Feel free to call your representative of Munson Engineering. They can also get you set up and work with my team. But we want you to try this. I want you to compare this to your RTK solution and your VRS solution and see, what it looks like. And then think of all the times that you've maybe just been stuck for an hour or two, not being able to work. would this help you in that situation? Would this get you out of a jam? Will this keep the crew working? Can you finish that job that day? Can you go out the next day and do another job versus going back out and finishing up where you left off the day before? So. And that's it for my time, everybody. Thank you. Any questions?
I just want to mention that the over-the-air activations seem to be working much better than they have in the past. So that 30-day trial, which would be over-the-air activation, I assume.
We can do both.
Yeah.
We typically do both.
In the past, it's been a little bit more difficult to activate. You have to go in through the receiver's interface, but with this over-the-air, it's pretty straightforward. It's easy to create a survey style and get it started.
Right.
Yes. That is magic to my ears. Thank you.
Typically, you can work with us and we can schedule a broadcast time. So if you know that you're going to be out, Tuesday afternoon at 4 p.m., you can let us know and we'll beam the broadcast down to you, Tuesday at 4 p.m. and you'll see, the screen flash. And next thing you know, you've got a RTX subscription.
Yeah, RTX has been, for the people that subscribe, there's no turning back. I mean, for how many times you've struggled with cellular coverage, or like you said, been out of the network, to be able to have another correction source that you can use, pretty huge time saver. Just think about the amount of time it would take to go and get your base, go back out, establish a base point, and like you say, maybe daisy chaining control. This can all be eliminated with this RTX correction.
Right.
No cellular coverage required. Pretty huge. So, any questions for Justin, guys, before we move on? Okay, I think we do.
Yes, sir.
Oh.
$1,995, so just under $2,000 per year per rover. Yep.
Can we use it with non-Trimble devices?
No, it's Trimble proprietary. Yeah, it's only going to be used with ours.
Can't believe you would even ask that question.
Well, no, I'm just saying, like, an RTK drone.
Oh,
Where
oh yeah.
I have like a DJI RTK drone
Oh, it's a good point.
Good question.
that does lose connection frequently.
Oh yeah, that's a great question.
So.
I didn't think about the drums.
All right, thank you.
All right, thanks, guys. Thanks, Justin. Appreciate it. Okay, let's do a couple, actually 3 giveaways, or should we do let's do the Slido first.
All right.
Do I need to unshare?
Yeah, most likely.